Alright guys, so today we're looking at rectangles. Remember, so far we've talked about parallelograms. Okay, and parallelograms are the start of our quadrilaterals unit. Okay, so remember that a quadrilateral is anything that has four sides. Okay, a parallelogram, if you remember, had to have opposite sides parallel, okay, and opposite sides congruent. So these are our parallel sides, and here are our congruent sides. Okay, so opposite sides congruent, opposite sides parallel. Today we take that one step further when we talk about rectangles. Okay, with parallelograms we had 5 properties. With rectangles we have 7 properties. The first 5 properties are the exact same properties that we have when we talk about parallelograms. Okay, so our first one is opposite sides are parallel. Okay, if we look at our picture here and we've got A, B, C, D, and let's call this intersection point E, then our opposite sides that are parallel are still BC is parallel to AD, and AB is parallel to CD. Okay, then we have opposite sides that are congruent. Okay, remember, congruent just means equal, so our opposite sides are also equal, which means they have the same length. Third, our opposite angles are congruent. Okay, I'm going to hold off on marking these, but our opposite angles would be A and C, and then we have B and D. Okay, next we have consecutive angles. Our consecutive angles are supplementary, which means they equal 180. And then we have our diagonals that are still going to bisect each other. Now remember that bisect means cut in half, so we have 2 equal parts. Okay, but we're going to hold off on marking that real quick also. Okay, so 6 and 7 are our 2 new properties. Okay, 6 defines how we figure out if it's a rectangle or not. Okay, for number 6 we have 4 right angles. Okay, we have to have these right angles at every corner for it to be a rectangle. If we don't have those 90 degrees, then it's not a rectangle. Okay, so those go in. Now remember, up here we said that our opposite angles are congruent. Okay, when we have opposite angles, we still have these alternate interior angles that would be equal. Okay, so those 2 angles would be equal. And then we're also going to have these 2 angles that are going to be equal. Okay, now our last property for rectangles is diagonals are congruent. Okay, what we're talking about here is the full length of our diagonals. So we would say that AC is equal to BD. Now if we know that AC and BD are equal, and we know that the diagonals bisect each other, then all 4 pieces of our inside diagonals are going to be equal. So AE would be equal to BE, which would be equal to CE, which is equal to DE. And that goes right here along with number 5. Okay, now if you look closely at this, you'll notice that we have some triangles formed on the inside here. Okay, remember when 2 sides are the same, okay, then we have an isosceles triangle. And remember that when 2 sides are the same, then those 2 angles that go with it are the same. So that's going to be one of our isosceles triangles right there. That would be triangle BEA. We have the same thing all the way around our triangle, which means we have at least 4 isosceles triangles. Okay, the other thing that you have to watch out for are these right triangles right here that look similar to this. Okay, this is triangle ACD, and that would be a right triangle where we could find the angles and so forth. Okay, like we've been doing. So let's look at some examples. It's important on these problems that you always mark what they tell you. Okay, so number 1 we have AE is 36, and we have CE, which is 2x minus 4. Okay, because the diagonals bisect, we know that those two pieces would be equal to each other. Okay, so we would get 36 equals 2x minus 4. All right, now I'm not going to solve all these problems for us today. I think you know how to solve them. I'm just going to set them up. If you need any extra help with how to solve, then come and see me or look up solving equations and go from there. Okay, so number 2 is similar but a little bit different. Okay, on number 2 it says if BE is 6y plus 2 and CE is 4y plus 6, find y. Now, if you remember from our picture right here, we know that all 4 of these pieces are all equal to each other. Okay, so we know that all 4 of these pieces are equal. So again, we can set up our segments as 6y plus 2 equals 4y plus 6, and then you would just solve for y from there. Okay, so those were both dealing with our diagonals. Okay, if we look at number 3, we see that BC is going to equal 24. Okay, and then AD is going to equal 5y minus 1. Here I'm talking about sides. Okay, and we know that these are opposite sides, so we know that they're congruent. So again, we would just set our sides equal to each other, and you could solve from there to find y. Number 6 is similar to that, but now we are looking at BD and AC. Okay, BD is a diagonal, okay, and this is our full diagonal, okay, or our whole diagonal. And we have AC, which is also a whole diagonal. And we know from our properties, number 7, okay, that our diagonals are congruent. So we could say 8y minus 4 equals 7y plus 3. Okay, again, you would just draw your line and then solve your equation to find y. Now, you do have to be careful on this one because it doesn't just ask for y on this problem. Okay, we get y minus 4 equals 3, add 4, and we get y equals 7. Okay, it asks us to find BD, so then you would just plug this back in. So 8 times 7 minus 4, which would end up giving you 52. Okay, so moving right along as we continue with our rectangles, now we're going to move into some angles problems. Okay, the most important thing with angles is that you trace it or you look at the vertex. Remember that your vertex is always the middle letter that we're talking about. Okay, so if we have angle BEA, then that means I'm talking about this angle being 62 degrees. Okay, now we have to look at what they want us to find. Okay, and what they want us to find is the measure of angle BAC. This angle, I'm going to call that angle X. Okay, now this is using our isosceles triangles that we talked about earlier when we talked about our properties. Okay, so what we're looking at here is we know that this side and this side are equal, which means this angle is equal to this angle X. Okay, now if you remember, we know that there's 180 degrees in a triangle, so we could say X plus 62 equals 180. Okay, then we get 2x plus 62 equals 180. Subtract that 62. We end up with 2x equals 118, and then we can divide by 2. Okay, and we end up getting x equals 59 degrees. Okay, so both of those angles would be 59 degrees, so BAC equals 59. Okay, now on 5, we're still dealing with angles, but now we're looking at some different angles. Okay, we have angle AED, so AED, this angle right here, is 12x. And the measure of angle BEC, this angle, is 10x plus 20. Now, this is from a while back, but our diagonals here, our intersection, form an X, which means we have vertical angles. Okay? So when we have vertical angles, we know that vertical angles are congruent, so we can say 12x equals 10x plus 20. And then we would just subtract 10x on both sides. 2x equals 20. Divide by 2 and x equals 10. Okay, now on this particular problem, it asks us to find the measure of angle AED. So we would say 12 times 10, which is 120 degrees. Okay, so our next problem looks a little bit different than that, but we are still dealing with angles. Okay, EBC is from E to B at C. Remember that vertex is at that middle letter, and that angle is 4x minus 6. Okay, then we have angle ABE, means we go from A, our vertex is at B, and we end at E, which means this angle is x plus 1. Okay, now remember that this is a rectangle, and our two angles right there at B have to make up that whole angle. And in a rectangle, we know that all of our corners are 90 degrees. Okay, so to find x on this problem, we're going to say we have x plus 1 plus 4x minus 6 equals 90. Okay, you add your x's together, you add your numbers together, and then you solve. So we get, add 5, we get 5x equals 95. And then we're going to divide by 5 to get x equals 19. Now they asked for the measure of angle at EBC, so we're going to go back and plug that into EBC and say 4 times 19 minus 6, which ends up giving you 70 degrees for the measure of angle EBC. Okay. Now I have one more thing that I want to talk to you about, and that's using slope to prove that this is a rectangle. Okay, when we look at is this a rectangle versus is this not a rectangle, we have to look and see if the sides are parallel and if our consecutive sides have opposite reciprocal slopes, which makes them perpendicular. Okay, now I've drawn the picture here for you already. Okay, and our points would be A is here, B, C, and D. So what we need to do is we need to find the slope of all 4 sides. So we're going to find the slope of AB and then BC and so forth. Remember that your slope formula is y2 minus y1 divided by x2 minus x1. Okay, now we're going to have to repeat this a couple different times, so if you need to label, then you feel free. Okay, the first thing that we're going to find is the slope of AB. Okay, so I'm going to use A and B. Our y's are 3 minus 1 divided by negative 3 minus a negative 3. Okay, so here we get 3 minus 1 is 2 divided by, remember minus a negative becomes plus a plus, negative 3 plus 3 is 0. Anytime you divide by 0, it's an undefined slope. Okay, again we're going to find 4 different slopes. Okay, so the next slope we need to find is the slope of BC. I like to go in this order, that way it just keeps everything going in one direction. So we've got 3 minus 3, because those are my y's, and then we've got 3 minus a negative 3. 3 minus 3 is 0, divided by plus a positive 6, and 0 divided by 6 is 0. Now, if you'll remember from perpendicular lines, okay, undefined slope is a vertical line, and our 0 slope is a horizontal line. So a horizontal line and a vertical line are opposite reciprocals. Okay, so they do form a 90-degree angle between A, B, and BC. So as we continue along, we're going to find the slope of CD now. Okay, and the slope of CD, we've got 1 minus 3, and we've got 3 minus 3, which gives us negative 2 over 0, and again, when we divide by 0, we get undefined. So here we see that AB is parallel to CD because they have the same slope. And we see that BC is still perpendicular to CD because we have 0 and undefined. So this is also 90. So then our last slope that we need to find is of DA. Okay, and we have 1 minus 1 divided by 3 minus a negative 3. 1 minus 1 is 0, plus a positive is 6, which gives us 0, which there we have our parallel top and bottom. And then 0 is perpendicular, or forms perpendicular lines with an undefined slope, so this is 90 and this is 90. So we would say that yes, this is a rectangle. Okay? And we could call it A, B, C, and D. Now, remember in the past, if we had slopes that were like 1/3 and -3 and 1/3 and -3, that those would also form a rectangle because these are opposite reciprocals and these are opposite reciprocals and these are the same slope. Okay? So this would be yes also. Your example for no would be if we had slopes that were like 2 and 1/2 and 2 and 1/2 because those are not opposite and reciprocals. Okay, these are parallel and these are parallel, but that's all we know. And so this would be not a rectangle, but it could be a parallelogram. Okay? So I hope that that has kind of helped you with rectangles. I think I'm going to stop there for today. Okay, but remember, opposite reciprocal slopes form a rectangle. You have to have 90 degrees to have a rectangle. Thanks.